This video, we're going to do examples of solving systems of equations using quadratics and linear. Previous video, I explained the different types of solutions you can have with linear quadratic and quadratic, the amount of solutions we could have. Our first example is a linear quadratic. So we could have 0 solution, 1 solution, or 2 solutions. So we're going to write out the steps for this. We have a system. The first one is y equals x squared minus 4, and the second one is y equals negative x minus 2. We're going to do this by hand. When you solve these systems by hand, you need to make sure that you set both equal to y. We need to make sure that they're both equal to y so that we're going to be able to use our next step. Since they're both equal to y, you could actually use substitution and replace this y value with this negative x minus 2. So that's one of the reasons why we want to make sure they're equal to the same thing. We can set them equal to each other. This is also called the transitive property. Transitive property. Because they're equal to the same thing, they must be equal to themselves or to each other. Once we have them set up equal to each other, we're going to just solve for x. Once we solve for x, we do need to get a coordinate to be able to have a solution to a system. So once we solve for x, we're going to substitute to find y, and then we'll have our coordinate. So our first step is making sure that these are equal to y. Since this one is already equal to y and this one's already equal to y, we're already good there. We want to set them equal to each other. So we have x squared minus 4 is equal to negative x minus 2. Now if we look at this problem, we still have a quadratic inside of it, and quadratic should be equal to 0 so that we can solve it. So that means we do want to get this quadratic equal to 0. So we have a positive x squared already. We want to keep the positive x squared, so we're going to move the negative x and the negative 2 to the left-hand side. So when we do that, we're going to add the x to the left, and we're going to add the 2 to the left. We end up with nothing that affects the x squared, so we have a positive x squared. We're going to add the x over, and that's our b term. Add the x. We're going to add the 2 to the negative 4, which is a negative 2. This will now equal to 0. The reason we did this is, since it's a quadratic, it will turn into a quadratic. We can try and factor this or use the quadratic formula to solve. So let's try and factor it. 1 times 2 will give us the 2, and 2 minus 1 will give us the 1. So that means that this will factor to x minus 1 and x plus 2. So we have x squared, 2x, negative x. So 2 minus 1 is 1. And then we also have negative 1 times 2, which is negative 2. So this is factored correctly. Now we're going to solve for x. I'm going to write this in red. My x value, we do the zero product property, which states that what value of x will make this factor equal to 0. It's going to be 1 minus 1 gives us 0, so x is equal to a positive 1. And for this one, negative 2 plus 2 gives us 0, so x will equal to a negative 2. Now we're not finished because we do have to substitute to find the y value. What we do for that is we do need to make sure we substitute the x value into both of these, because if it works for one but not the other, then it's not a correct answer. So we do need to make sure that we get the same y value out for both of these equations. So I'm going to write it up here. So x equals 1. That's the value I'm substituting. We have y equals parentheses 1 parentheses squared minus 4. That is equal to a negative 3. So as long as this is also equal to a negative 3, that means that we've done it right and we do have a solution. So y equals negative parentheses 1 parentheses minus 2. Negative 1 minus 2 is equal to negative 3. That means that the y value is in fact negative 3. One of our solutions was 1 comma negative 3. We plugged in the x, we input the x, we got the output of the y. We inputted the 1, output of negative 3, so 1, negative 3 is our solution. We also want to try out the negative 2. So when we do x equals negative 2, we're going to do the same thing. Y equals parentheses negative 2 parentheses squared minus 4. That's equal to negative 2 squared is positive 4 minus 4 is 0. Then we do y equals negative parentheses negative 2 minus 2. Negative times negative 2 is a positive 2, minus 2 is 0. So these are the same. That means that our other solution is at negative 2, comma 0. We have the input of negative 2, we got the output of 0. So these are our two solutions. So that means that our parabolas will cross twice. It'll look more like this one, where one is opening up, the other is opening down, and it crosses at two locations. I'm going to skip the U try. I want you to try that on your own. I'm going to go on down to quadratic. The quadratic we set up the same way. We have to make sure that they're both equal to y, or equal to the same thing. So they are both equal to y. That means we can set them up equal to each other. So we'll have x squared minus 3x plus 4 is equal to negative x squared plus 4. And again, we have two quadratic terms. Since it's a quadratic, we need to get it equal to 0. So we have a positive x squared, we have a negative x squared. Let's add the x squared to the other side. So if we add this x squared, it becomes a 2x squared. We're going to subtract the 4, so we will not affect that negative 3 at all. So negative 3x stays. We're going to subtract the 4, so 4 minus 4 is 0. So this is now just equal to 0. We only have two terms, and they both have an x in it, so that means we can factor out the GCF of an x. So let's factor that out. X parentheses, then we're going to have 2x minus 3 parentheses equals to 0. This has been factored, and now that our x's are separated, we can solve by factoring. Again, zero product property. The value of 0 will make this 0. So our first solution is x equals 0. Our second solution, if we set this equal to 0, we would add the 3 and then divide by 2. So x is equal to a positive 3 over a positive 2. So we have our two x's, but we need to get a coordinate. So we're going to do the same thing we did up here by plugging in our individual x's into both of our equations so that we can make sure that our y values do match. So for this first one, we have x equals 0. X equals 0. We're going to plug it into both of these. Y equals 0 squared minus 3 times 0 plus 4. This will just equal to 4. And then y equals negative 0 squared plus 4. This also equals to 4. So they are both equal to 4. That means that our solution, the x value was 0, the y value was 4. The second one is 3 halves. I'm just going to write that as a decimal. So x is equal to 1.5. So when I plug it in, y equals parentheses 1.5 parentheses squared minus 3 times 1.5 plus 4. If I were to plug this into my calculator, I'll get the value of 1 75/100. 1 75/100, or 1 3/4. Do the second one, y equals negative parentheses 1.5 squared plus 4. If I plug this into my calculator, I'll get the same 1 75/100. So since these y values are the same, we do in fact have a coordinate. The x value is 1.5, comma, the y value is 1 75/100. So this one, we also have two quadratics crossing each other. So on the first one, we had a quadratic and a line crossing twice. So we had this parabola and a line crossing twice. It's not the exact same picture or anything. It's just showing the representation of it. And on this one, the second problem, we had a parabola opening up and a parabola opening down. So it is opening up, opening down, and it is crossing twice. Now, the last thing I'm going to show is how the steps in the calculator. The first step to be able to do this in your calculator is to get both or all equations in y equals format. That means solve for y. So if they're already in that format, that's great. If they're not, you need to make sure that they are, because you are going to graph them in your calculator. The second step is you put the first equation in y1 equals, and then the second equation in the y2 equals inside your calculator. If you have a third one, you would put the third one into y3. You just have to make sure that they're separated into two different ones. The next step is you actually want to look at the graph. So you want to graph it. Look at the graph to see the intersection or intersections. But you actually want to see them to see if it's even going to have intersections, because you don't want to have to do all the process if you can see that they're not going to have a solution. The fourth step, once you've determined that there are solutions, you're going to press the buttons second, trace, and then you want the intersect, which on most, it should be number 5 on TI 83 or 84 calculators. But you'll only do second, trace, intersect, because you want to calculate the intersection. Now, if there are multiple intersections, you will have to pick one at a time. So we're going to, once we get back to the graph, we're going to move the cursor left or right. So move the cursor to an intersection. You'll just move it to one of the intersections. So you'll see where they're crossing, move it to one of the intersections. And then step 6 is you'll just press enter 3 times. If there is more than one intersection, you'll repeat most of this. You'll just have to repeat the second trace intersect, and then you'll just go to the other intersection and press enter 3 times again. So an example, I'm going to do this one example on the side. In my calculator, I want to get both or all equations equal to y, and both of these equations are equal to y. We're going to type the first equation into y1 and the second one into y2. So I'm going to go to my y1, go to my y equals button right up here. In my y1, I'm going to type my first equation, so I have my x squared, which the squared button's right here, plus 6x plus 8. My second equation, I'm going to press down, go to y2. I'm going to type in the negative 5x squared plus 18x plus 32. Now if I'm looking at a basic graph, I should go to zoom 6. I just press graph. There's my first parabola, and there's my second parabola. Now notice on here I only see them crossing one time, but we know that this parabola is opening up and then this parabola is opening down, so it should cross more than one time. So if I want to be able to see this, if we go to zoom, there's multiple different zooms you could do. You could zoom out if you wanted to. You could do, zoom standard is the 10 by 10 window, which we were already in. I'm going to scroll down. There is zoom stat, which is not the one we're going to use, or there's zoom fit. Now zoom fit will distort the graph, but it will at least fit to the general window you need, and then you could zoom in or out from there. So we're going to do zoom fit to at least fit the graph to see if we can see our intersections. I'm going to press enter on zoom fit. It's going to regraph. So here's my first parabola, and here comes my second parabola. So we can see how this one went up and then back down, and you can see that it will cross twice. Now I could zoom in on here. Let's just see what happens on that. So if I press zoom and I press 2, now nothing actually happened, it just went back to the screen, but I can move my cursor to be like, I want to zoom in this area so I can easily see things. So once I get to the area of where I want to zoom in, now I can press enter. So we might not even see both of the intersections again because I zoomed in, which is fine. I just wanted to show that you could do zoom in once you get to that zoom fit. So let's see what happens. we want to do the next one is second trace intersect. So I'm going to press second trace, then I want the intersect button. Now here's my cursor. I can easily see this intersection, so I'm going to press right until I get to that intersection. Or at least close to it, because I won't get perfectly on it, but I'm at least close to it. Now I'll press enter 3 times. 1, 2, 3. My intersection is at 3 and 23 hundredths, or 3 and 24 hundredths, comma, 37 and 89 hundredths. So I'm going to write that down. 3 and 24 hundredths, comma, 37 and 89 hundredths. It's my first solution. Now, I'm going to repeat the second trace intersect, but this time I'm going to try and go over here to see if it will give me my intersection. Because I zoomed in, it might not give me the intersection. We might have to just zoom back out, but that's something that we will determine. So I come over here, I get closer and closer to it, and if I keep going, it does actually move the graph some, so even if I can't see it, I moved it enough to where I don't have to zoom out again. So I just want to get closer to that curve, to the intersection, and I'm there. So I'm going to press enter 3 times. 1, 2, 3. My other intersection is at negative 1 and 24 hundredths, comma, 2 and 11 hundredths. Negative 1 and 24 hundredths, comma, 2 and 11 hundredths. And these are our two solutions using our calculator. So again, you just have to repeat the second trace, and we want the intersect. And then you would just move it to the other intersection of the one you hadn't already done yet. You don't have to re-graph everything.